What's up, y'all? It's Motorman, and today we are troubleshooting the high pressure injection system on this 2012 Hyundai Accent GDI. So the way this works is it has a conventional electric fuel pump in the fuel tank that pumps it up to this here high pressure fuel pump, just much like a diesel, you know, anything with direct fuel injection. It runs anywhere from like 600 to 2000 psi. And so this car, it was having trouble starting. It was running rough. It had a loss of power, and this computer is actually designed to put it in limp mode if it has any problems. So it's got a like I said, electric fuel pump in the fuel tank with a fuel sending unit. That's your gas gauge, just like any other indirect injected car. And that pumps the fuel up through this line into the high pressure fuel pump. Let's see if I can get it. There we go. And then it's regulated. It's a returnless system, so it's regulated by this, it's like a diaphragm that's directly controlled by the ECM, which allows more or less fuel to flow into the high pressure fuel pump, which is this guy. It's controlled, it's actually actuated by the camshaft on the engine. And then high pressure fuel comes out of this line and goes down under the intake to the fuel injectors, and then there's a fuel pressure sensor on the fuel rail under the intake. So with the scan tool, we can monitor the open angle of the fuel control valve for the high pressure fuel pump and the actual voltage level of our fuel rail pressure sensor. So at idle, it's supposed to be like 1.5 volts, which, and on the scanner I'll show you, it gives us a target pressure and actual pressure. So I did a few checks on it to make sure those sensors were actually working properly, to make sure it was actually the pump that was bad. But let me show you what I got here. So if you look at our scan tool, this is the angle of open. That's how much, if it's demanding more fuel, it'll open that valve more or less. So like 100%, you know, 100 whatever is fully open. And then we've got our target fuel pressure and our actual fuel pressure, and I'm pretty sure this is a derived value from the voltage on the rail sensor. So it wouldn't start at all yesterday, but now it starts. It just runs like crap and you can't drive it. So let's start it. So now it's cranking, but it won't even start. There we go. So look at our target fuel pressure, our actual fuel pressure. It's garbage. And it's opening that thing up as much as it can for as much fuel as possible, and it's just not getting it. Our voltage is supposed to be 1.5 volts at idle and up to 3 volts at like 6,000 RPM. It's at 0.6. It's very low because the actual fuel pressure is 117 and it's calling for 600. So you can see if you give it gas, the demand pressure goes up. But it's not giving us anything. So this is pretty short and sweet, but this high pressure fuel pump assembly is bad because it has all these parts in it: the regulator and the pump. And I'm pretty sure our rail sensor is working fine. So we're going to put a fuel pump in this thing, the high pressure mechanical fuel pump, and check it again. So I got my parts in today. Let me show you guys what this thing is doing. So here's what it's supposed to look like. You can look at our fuel pressure regulators, only like 25% demand. Our target pressure and our actual pressure are right in line with each other, and we've got 1.3 volts on our fuel pressure rail sensor. And you can watch these values move up and down with the RPMs. You can see your target pressure and your actual pressure are following each other. It's exactly what it's supposed to do.